In the world of programming, an edge case is an input or scenario that lies on the outer boundaries of what your code is designed to handle. These are the unusual, the unexpected, the values that can make your carefully crafted logic crumble. Imagine a program that calculates the average age of users. An edge case could be an input of 0 users, a negative age, or even an age so astronomical it overflows the data type. Edge cases often stem from the fact that real-world data is messy and unpredictable. Users might enter incorrect formats, data connections might be lost, or external APIs might return unexpected responses. While we strive for clean and predictable inputs, edge cases remind us that reality rarely conforms to our ideal scenarios. Failing to account for these unusual cases can lead to a cascade of problems, from minor glitches to complete system failures. A seemingly insignificant oversight, like not accounting for an empty input, can snowball into a critical vulnerability, compromising data integrity or even bringing down an entire application. This is why recognizing and addressing edge cases is not just a good practice. It's an absolute necessity for writing robust and reliable software. As programmers, we often fall into the trap of happy path thinking. We focus on the ideal scenario. The user enters valid data, the network connection is stable, and the code executes flawlessly. This tunnel vision can lead us to overlook the less obvious, less intuitive cases lurking at the edges of our logic. Time constraints and tight deadlines further exacerbate this tendency. When we're rushing to meet a launch date, it's tempting to prioritize core functionality over what seems like unlikely scenarios. We convince ourselves that we'll circle back to handle those edge cases later, often forgetting them in the process. However, this approach is akin to building a house on a shaky foundation. Ignoring edge cases is not a time-saving tactic. It's a technical debt that will inevitably need to be repaid, often with interest. The longer we postpone addressing these vulnerabilities, the more deeply embedded they become in our code base, making them exponentially harder and more expensive to fix in the future. The consequences of neglecting edge cases can range from minor annoyances to catastrophic failures. At best, overlooking an edge case might lead to a minor bug, a validation error message that doesn't display correctly, or a calculation that returns a slightly inaccurate result. However, the implications can be far more severe. In mission-critical systems such as those used in healthcare or finance, ignoring edge cases could have life-altering or even fatal consequences. A medical device that fails to account for an extreme value could malfunction, leading to incorrect dosages or misdiagnoses. A financial algorithm that doesn't consider a rare market condition could trigger a cascade of erroneous trades, resulting in substantial financial losses. Even in less critical applications, the impact of ignoring edge cases can be significant. A website that crashes when a user inputs an unexpected character can lead to frustration and lost revenue. A mobile app that freezes when the device loses network connectivity can damage the user experience and lead to negative reviews. Section 4. Mastering Edge Cases. Practical Strategies for Robust Code. Developing a keen eye for edge cases is crucial for writing robust code. Here are 3 steps to avoid pitfalls. 1. Ask what could break my code. Cultivate skepticism. Actively try to break your code. 2. Write defensive code. Anticipate problems before they arise. Incorporate checks and validations. Use conditional statements. Handle errors gracefully with try-catch blocks. 3. Test for edge cases. Ensure your code doesn't break under unexpected circumstances. Dedicate testing efforts to edge cases. Test with empty inputs, invalid data types, and large numbers. Section 5. Edge cases, the hallmark of a thoughtful programmer. In conclusion, considering edge cases is not about obsessing over every possible exception. It's about adopting a mindset of thoroughness, anticipating potential problems, and writing code that's resilient enough to handle the unexpected. It's about understanding that the real world is messy and unpredictable, and our software needs to be equipped to handle that gracefully. By embracing edge cases as an integral part of the software development process, we elevate our craft from merely writing code that works to building systems that are robust, reliable, and trustworthy. It's a hallmark of a thoughtful programmer, one who understands that true mastery lies not just in solving the problem at hand, but in anticipating and mitigating potential problems before they even arise.